Okay, so for number 15, we're asked to list the possibilities for the nature of the roots of each equation. All right, so if you use Descartes' rule of signs, which is on page 378 at the bottom, you're looking for how many times the sign changes, okay? So that's positive to positive, positive to positive, positive to positive. There were 0 sign changes. We didn't have any negatives in here at all. So what does that mean? That means we have 0 positive real number roots. So there aren't any solutions to this that are in the positive numbers. We can tell that just by looking at the signs. Okay, now, but what about negative real number roots? In order to determine the negative real number roots, if you remember what we have to do according to Descartes' rule of signs, is everywhere we see an x, now I'm just putting parentheses for those, we're going to substitute a negative x, okay? And that's going to help us tell how many negative reals there are. All right. When you have an even exponent on a negative number, it just ends up being positive. So this is just going to be x to the 4th. But here we got an odd exponent, so this will be minus 2x cubed. Here we have an even exponent. Negative x times negative x would be positive x squared plus 1. Okay? So this is a little bit different than what we started with. This is not an, remember we called it an even function if you get the exact same thing when you put in x and negative x. And on number 13, if you watched that video, you saw that was an even function. This one is not because it's a little bit different than what we started with. So let's count the sign changes. There's one here because it goes from positive to negative. There's another one here because it goes from negative to positive, and then positive to positive. Okay, there's no sign changes there. So there are 2 sign changes, so that means there's 2 negative real roots, or there could be less than that by an even number, which means subtract 2. Well, 2 minus 2 is 0. So far we got this possibility. We've got 0 real positives, 2 real negatives, but we could have had 0 real positives and 0 negatives, okay? Now, imaginary. We find the amount of imaginary roots by counting up how many positive and negative real number roots there are and subtracting it from the total number of roots. The total number of roots here is 4 because the biggest exponent is 4. So if there are 4 roots, because the biggest exponent is 4, and you look at the first situation here, if you have 0 positive and 2 negative, 4 minus 2, 4 total minus these 2 negative leaves 2 imaginary roots. So there's one scenario right there. But remember, it could have been 0 positive and then 0 negative, and then how many imaginaries would you have? Well, if you have 4 roots in all, 0 plus 0 is 0. 4 minus 0 leaves 4 imaginary roots. So there were 2 possibilities for number 15 on 8.6. Okay, this problem, this one right here, we're trying also to see the nature of the roots of each equation. And remember that what we're doing is we're saying, okay, how many positive roots could there be real roots? How many negative real roots? And then how many imaginary roots? And we know that in total, the total number of roots we're going to have here is 5. Total of 5 roots because the biggest exponent is 5. All right, so let's start figuring this out. I'm going to just kind of make a table over here to list our possibilities. Now, for the positive roots, we just look and we see how many sign changes there are. Well, this x to the 5th is positive, so a positive to a negative leaves me 1 sign change. That's a negative to a negative. From here to here, no sign change. But a negative to a positive is 1 sign change there. And then a positive to a negative is another sign change. That means there's we could have up to 3 positive real roots. But if you read the first part of that Descartes' rule of signs theorem, it says that you could have an even number less than that. So if you subtract 2 from 3, you also have a possibility of just having 1 positive real root. Okay? So far that's our possibilities for positive real roots, 3 or 1. Okay, so let's go check out the negative roots. If you remember, what we do is everywhere we see an x, we plug in negative x. And that's the second part of Descartes' rule of signs. So let me go do that. Now, this is going to get a little tricky here. When one thing I'm going to do is I'm going to copy down all the adding and subtracting signs that we have here. Okay? And then look at what's coming out of just the negative x raised to an exponent. This negative x to the 5th power, because it's an odd exponent, it'll be negative x to the 5th. This odd here, odd exponent of 3, means this is going to be negative x cubed. Okay? Now this negative x to an even exponent will just turn out to be x squared. And then we've got plus minus x, so that would just be minus x. And I'm just going to rewrite that as minus 2. Let me clean that up a little bit. That's negative x to the 5th. This minus and a minus make a plus x cubed minus x squared minus x minus 2. Let's see how many sign changes we have on this one. This will tell us how many negative real roots we could have. Positive to a negative, there's 1. I'm sorry, a negative to a positive, there's 1 sign change. A positive to a negative, there's another sign change. But a negative to a negative, no sign change. This negative to that negative, no sign change. So it looks like there's a possibility of having 2 negative real roots, or an even number less. So 2 minus 0 would be 0 negative roots. So here's what's going on. We could have 3 positive roots and 2 negative roots, but we could also have 3 positive roots and 0 negative roots. Likewise, we could have 1 positive root and 2 negative roots, or 1 positive root and 0 roots, because you've got these, you had 2 possibilities with the first thing for the positive roots, and we got 2 possibilities here. All we got left to do now is figure out the imaginary roots. I'll do those in like green over here. If we have a total of 5 roots, 3 roots plus 2 roots is 5 roots, so that would leave none for the imaginary roots. On the second line, if you have 1 positive and 2 negatives, that's 3 total, and 5 total roots minus those 3 would leave you 2 imaginary roots. If you had 3 positive roots and 0 negative roots, that's 3. 5 minus 3 would leave you with 2 imaginary roots. And if you have 5 total roots and only 1 positive, no negatives, 5 minus 1 would leave you with 4 imaginary roots. So we have 4 possibilities here. Each one of those rows gives a different possibility.